Okay, as we start chapter 6, we're going to be looking at what are called functions, and they're actually very, very similar to equations or expressions that we've been dealing with in the past few chapters. So we're going to be on page 121 of your workbook. But before we start working on these activities, I just want to give you a very basic definition of what a function is and what a relation is and what the difference is between them. So this is a page straight out of the textbook for the first lesson in chapter 6. And the first thing that it shows here is a set of ordered pairs. We have 0, 1, 1, 2, and 2, 4. Each of the x values in the ordered pairs are what are called inputs. And each of the y values are what are called outputs. So, very basic definition of what a relation is listed right here. All a relation does is it pairs an input with an output. So, an ordered pair is a relation. You can also show it by what's called a mapping diagram. And if you look at this part right here, it basically looks like an XY table. But instead of X, they put input, and instead of Y, they put output, but they are essentially the exact same thing. So if you think of a vending machine, if you put in a certain amount of money, if you input the money, you get out whatever it is you were getting, so a soda, candy bar, something like that. You put something in, you get something out. If you have an equation, you put in your x values into the equation wherever x was, and you get out whatever y was. So that's very basic definition of what a relation is. We'll get more into detail with those later, but two different ways you can look at them, either ordered pairs or separating them out into a mapping diagram, input, output table. So if you look at your workbook, on activity 1, we're basically going to be filling out these mapping diagrams over to the side. So on part A, they are wanting you to find the area of the rectangle. So you guys know to find the area of a rectangle, we take the length times the width. So in this case, it's going to be 2 times x. Well, they've given us a list of input values right here, so all we're going to have to do is make the x each one of these numbers, and we'll put our answers right over here in the output column. So if x is 1, my area would be 2 times 1 is 2. If my x is 2, 2 times 2 would be 4. If it's 3, 2 times 3 would be 6. If it's 4, 2 times 4 would be 8. So each one of these inputs gives you a specific output once you plug it into the equation. Okay, part B is going to look at the perimeter of the rectangle. So again, perimeter, you just add all the sides together. So if this side over here is 2, that means the side opposite from it will also be 2. And if this side is x, this side up here will also be x. So I want to clean that up and make it look a little simpler. So we'll have x plus 2 plus 2. And if I combine those like terms, I have 2x plus 4. That will give me whatever the perimeter will be. So if I start plugging in these input values, or these x values over here, if I plug in 1, 2 times 1 plus 4, well, 2 plus 4, that would give you 6. If I plug in the number 2, 2 times 2 is 4, plus 4 would be 8. If I plug in the number 3, 2 times 3 is 6, plus 4 would be 10. And then finally, if I plug in 4, 2 times 4 is 8, plus another 4 would give you 12. So really all we're doing on these is we're taking the x values that they give us and plugging them into an equation for whatever they're asking us to solve. And our answers go right over here in the output column. On part C, they are asking us for the circumference of a circle. Okay, and the circumference of a circle is 2 times pi times r, which is the radius, the distance from the center of the circle out to the outer edge. Now notice on your input column, they are labeling that as r. This is what your radius would be. So if your radius was 1, what would the circumference be? So all I'm going to do again is just plug these straight into my equation. So 2 times pi times 1. 2 times 1 is 2. And then I'm just going to leave the pi symbol in my answer for right now. Okay, if I plug in 2 for the radius, 2 times pi times 2. Well, 2 times 2 is 4, so this would be 4 pi. Okay, if I plug in 3, we have 2 times pi times 3. 2 times 3 is 6, so this would be 6 pi. And then finally, I'll have 2 times pi times 4 for the last one. 2 times 4 is 8. So this would be 8 pi. And we could have gone through with each of these. And you know that pi is represented with 3.14. So we could have done 2 times 3.14 to get a more exact answer. 4 times 3.14, and on down. And then finally on D, they want us to find the volume of the prism. So remember, volume of a rectangular prism is length times width times height. Just multiply the 3 sides together. So our input column, they've given us what the height would be. So if the height is 1, we would take 3 times 1, which gives us 9. If I put in 2 for the height, we have 3 times 3 times 2. Well, that's 9 times 2 is 18. If I have 3 for the height, that would be 3 times 3 times 3, which is 27. And then finally, if you have 4 as the height, 3 times 3 times 4 would give you 36. So again, all we did on this page was we took an equation for either the area, perimeter, circumference, or volume, and we plugged in these input values that they gave us. And our output was whatever we got for the answer for the area, perimeter, volume, whatever we were dealing with. Now, on the next page, page 122, Activity 2, it just simply says how many outputs are assigned to each input. And then describe a possible situation for each mapping diagram. So if you look at part A, it says we have 4 inputs, 12, 23, 30, and 48. 12 goes with 6, 23 goes with 15, 30 goes with 20, 48 goes with 13. So on this one, each input has only one output. Each one is just assigned one output. If you look at part B, if you notice, the input of 10 goes with 0 and it goes with 1. 11 only goes with 0. 12 goes with 1 and 3. And 13 only goes with 2. So we're going to say inputs 10 and 12 have 2 outputs, and 11 and 13 have 1 output. Now this is going to be a big deal as we start looking at the definition of what a function is. Each of these are called relations because they have inputs and outputs being paired together. It doesn't matter what they are. But the definition of a function is whenever each input has only one output assigned with it. So on part A, that is the straight definition of a function, when each input has only one output. Okay, so part B, this would not be a function, because just for the fact that 10 is assigned to 2 different outputs and 12 is assigned to 2 different outputs, they each can only have one. Okay, then moving on to activity 3. It says describe the pattern in the mapping diagram and complete the pattern. So if you look at the input column, notice each one goes up by 1. In the output column, the 3 that they've given me, I notice a pattern that they're adding 2 every time. So I can very easily complete this table. I know the next one would be 14, 16, 18, 20 because they're going by 2s. So describe the pattern. The input increases by 1 as the output increases by 2. Simply the pattern going on there. Okay, then if we keep moving on, part B, notice your inputs go by 1 each time again. So that's nice. Inputs increase by 1. As the outputs, now if I look at the output, I have 4/3, 5/3, and then 2. But what I know is 2 is the exact same thing as 6/3. So right here you should see a pattern. 4/3, 5/3, 6/3. Next will be 7/3, 8/3, 9/3, which that would be equal to 3, and then 10/3. So the outputs are increasing by 1/3 each time. Now the last thing I want to talk about in this video is anytime you have an input-output mapping diagram like this, every one of these can be written as an ordered pair. So the very first one is assigned to 4/3. That would be an ordered pair of 1, 4/3. So if you were to graph it, you'd go over 1, up 4/3. And you could do that all the way through with every single one of them. Okay? Now, if we go back to the previous page, on page 122, and I'm going to look at part B right here. You could still do it even though every input, some inputs have multiple outputs. You just have to write those twice. So 10 goes with 0 and 10 goes with 1. 11 went with 0. 12 went with 1 and 12 went with 3. And then finally 13 went with 2. So you could go back and forth between these two. If they give you a mapping diagram, you can write the ordered pairs from it. If they give you ordered pairs, you can write a mapping diagram from it as well. So now I want you to flip over to the page that says 6.1 practice and complete that page.